Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. Time to illustrate the limit of a piecewise function using a table of values. A piecewise function is a function that has multiple definitions. It's just like this function here. Let's say f of x is equal to, written as this, you have x plus 2 if we use values of x greater than, let's say, 3. Okay. However, we also have here x squared minus 1 if we pick those values of x less than or equal to 3. So this is an example of a piecewise function because we have two definitions here. We're going to use x plus 2 if we're taking about values of x greater than 3. But if we're going to use values of 3 and all the values to the left of 3, we're going to use x squared minus 1. So if we have here the limit of the function, we are going to write f of x instead of the entire description because it depends now on which to use. As x approaches, let's say, 3, we are still going to use the same idea as before. As here, we are going to illustrate that using a table of values. But it's very important to remind ourselves that the limit of the entire function is only possible if the limit of the function as the x approaches a 3 from the left and from the right are the same. So let's start here from the left. If we are going to start from the left, let's try to look at the possible expression to use. Since we have 3 here, and from the left of 3, we're going to use the second definition, as this is the expression for values of x less than or even equal to 3. So if we're going to start that, again, this is from the left, give us from a number from the left of 3, let's say 2. If we're going to substitute that in our given here, we have 2 squared, okay, is 4 minus 1, I have here 3. Okay, that's the value of our f of x. Now let's pick other values getting closer to 3. Yet let's say 2.5. Okay. Since this value is still less than 3, we're still going to use x squared minus 1. So you have the square of 2.5 is equal to 6.25. You may use your calculators if you would like to. Okay. And then you will subtract 1, you will have 5.25. Okay, that's 2.5 square, okay, is 6.25 minus 1, that's 5.25. Next, let's try 2.9. Okay, the square of 2.9 is equal to 8.41. Okay, that's 8.41, and then minus the value of minus 1, you will have here 7.41. How about if we have 2.99? So we're getting closer to 3, but we will not touch a 3 because that's the idea of the limit. So you have 2.99 times 2.99, you will have 8.9401 minus 1. Okay, you will have a result of 7.940 and 1. If we have here the last number, let's say 2.999 and 9. Okay, 2.9999 times itself is equal to 8.9994001 minus 1. You will have here 7.9994001. So just this is already okay. As we move from the left of 3 going towards 3, we could see a trend on our values here as this will approach to a certain value, integer, in this case 8. Okay, you can even try values closer, still closer to 3, and you will have to be closer to 8. That's the value of this piecewise function as x approaches to 3 from the left. Now let's have from the right. Okay, so let's try a value from the right of 3. Let's use 4. But this time, we will not be using the second expression. We'll be using the first expression because this is the definition of this piecewise function if x is greater than 3, which includes 4. So 4 plus 2, that's simply 6. Okay. Next, we are going to use here the value closer to 3. Let's say 3.5. 3.5 plus 2, of course, you don't need calculators for that. You have 5.5. Okay. Next, let's have 3.1. So that's also 5.1. That's simply plus 2. If we have 3.01, okay, plus 2, you have 5.01. If you're going to try here 3.0001, the limit or the value of the function as this gets closer to 3, this is still greater than 3, so we'll be using x plus 2, so you have 5.0001. Now as we get closer to 3 from the right, the trend of our f of x is getting closer to 5. This is the other side, from the right side. So now that we are done with the two, let's examine the values. We have here 8 and this is 5. They are not the same. Since the limit from the left and from the right of the given piecewise function f of x are not the same, then the limit does not exist. By the way, we need to emphasize this. We cannot say equality, because does not exist means there's no exact value in terms of the real numbers, right? Or there's no or the limit does not exist. We cannot say equal to dne, because dne is not a value, simply does not exist, or denoted as d and e, because the limit will only exist if the limit from the left is equal to the limit from the right. This is how we show or illustrate the limit of a piecewise function using table of values. But of course, there might be some piecewise functions that will satisfy a certain limit. Just for this case, our example, the limit does not exist. So what are you waiting for? Subscribe now!